question 4 of the practice test, we need to write various expressions in the form ax to the n. The first one is 1 over x cubed. Now, if an expression is in the denominator and you want to effectively bring it up to the numerator, what happens is that the power turns to a negative. So in this case then we have the 1 in the numerator anyway, and instead of dividing by x cubed, we're now going to multiply by x to the minus 3. So dividing by x cubed and multiplying by x to the minus 3 are exactly the same thing. So the value of the expression is exactly the same. We've just changed the format of it. And then 1 times x to the minus 3 is simply x to the minus 3. Question 4 part B, we've got root x, and again we want to write it in this form ax to the n. Now if you have square roots involved, or cube roots, or fourth roots, that is same as a fractional power. So in this case there is an invisible little 2 there for a square root, and because of that invisible little 2, the power of x in this case is 1 over 2, and so the 2 of the half there is effectively that invisible 2 that's in front of the square root, so we get x to the half. Question 4c, we have 1 over 6 root x, and we need to express that in the form ax to the n again. This time we have the x in the denominator, and we also have it rooted, so it's a square root of x in the denominator. So there's effectively 2 things going on there. And we also have the 6 as well. Now what helps here is if we actually separate off the 6 from the root x and effectively break up the fraction overall to make it a 1 over 6 times by a 1 over root x, and you can just double check for yourself that if you multiply those two together, you sure enough get back to 1 over 6 root x. Now the advantage of doing this is that the number bit is separated out. We now know we have 1/6 as our a, effectively, the number bit at the front. The algebra bit, the 1 over root x, we have 2 things going on here. We have a square root of x. Now we could do one step then, which is to turn the square root of x into x to the half, like that. And then we could do the final step where we turn the 1 over the fact that we did dividing by x to the half, we turn it into a multiplication, which will be x to the minus a half. Okay, so overall then we would get 1/6 x to the minus a half. Question 4d, we have 4 over 7x to the 6, and we need to write that again in the form ax to the n. So as in part C, I would suggest you separate off the number bit, the 4/7, from the algebra bit where we have x to the 6 in the denominator. Now we need something in the numerator. If we're going to express it as the multiplication of 2 fractions, that's going to have to be a 1, so that the 4 times the 1 makes the 4. So these 2 things multiplied together still get us back to our original expression. We've now got the number bit sorted. The value of a then is the 4/7. The algebra bit, 1 over 6 to the x, well, we can, instead of dividing by 6 to the x, we can say, well, that's a multiplication by x to the minus 6. And then there we have our final answer. Question 4 part E is turning the expression square root of 36x cubed into the form ax to the n. Now surds, if they're multiplied on the inside, we can split them into 2 separate surds which are multiplied together. So we can split this up into root 36 times by root of x cubed. Root 36 is clearly 6, and x cubed, well, that's x cubed all to the power, well, it's all square rooted, and square rooting is the power of a half. So power of a half is the same as square rooting, just in question B, I think it was. And to finish off then, we need our rule of indices, which is that if we have brackets, we can multiply the powers together. So 3 times by a half is 3 over half, 3 over 2. 3 halves of 3 over 2. So then we finish then with 6x to the 3 over 2. Question 4f. Here we have the cube root all over x to the 5 over 64. And we need to express that in the form ax to the n. Okay, well there's various ways we could go about this, but to start with I would suggest we push the cube root into the numerator. So we have cube root of x to the 5 and the denominator separately, so cube root of 64. Okay, and the rules of absurds allow us to do that. Then the cube root of 64, well that is just 4. And the cube root of x to the 5, well that's x to the 5 cube rooted, and cube rooting is the same as raising to the power of 1/3. So cut the denominators of 4 down. In the numerator then we have x to the 5 all all to the power of a third, and rules of indices allow us to multiply the powers together there. So when we have brackets between two separate powers, we multiply the powers together. So here we have 5 times a third, which is 5 thirds. Now it's almost in this form ax to the n, but the a really should be a separate number at the front with the x to the 5 thirds towards the side. So a slightly neater way of writing this then would be to see that that is, in the numerator we've got an invisible 1 as a number there in front. So overall we've got a fraction of 1/4, and that has been multiplied by x to the 5 thirds. And that's just more in keeping with the form ax to the n. Question 4g, the last part of this question 4, which is where we put in expressions into the form ax to the n. Okay, so we have 5 over 2 cube root x all to the power of 4. Now the whole thing to the power of 4 means that that power of 4 can be pushed inside, so that every component of the inside gets raised to the power of 4. And you can prove to yourself that that's true if you wanted to by multiplying the 5 over 2 cube root x by itself 4 times. And so as you can see we've got 4 5s that are multiplied together, which is 5 to the power of 4. 2 appears 4 times, so that's 2 to the power of 4, and the cube root of x appears 4 times, so that's cube root of x to the power of 4. So let's tidy up the numbers to start with. So 5 to the power of 4, well if we're not too sure what that is, we can check that on our calculator. So 5 to the power of 4, 625. 2 to the power of 4 is 16, and cube root of x to the power of 4, well the cube root of x can be written as x to the power of 1/3. Remember the little 3 in front of the root sign there is effectively the denominator of our fractional power. So the cube root of x is x to 1/3, and then we've got the power of 4 copying down there as well. Okay, let's just tidy up that denominator then. So x to the 1/3 all to the power of 4, we can multiply the powers together again. So we've got x to the 4 thirds there, so 1/3 times 4 is 4 thirds. This gives us then 625 over 16x to the 4 thirds. Now at this stage, as you may have seen in the previous videos, it's helpful I think to separate off the numbers, so 625 over 16, and the algebra bit, so 1 over x to the 4 thirds. Now the 1 over x to the 4 thirds, instead of then dividing by x to the 4 thirds, we can instead write that as a multiplication by x to the negative 4 thirds, and that is effectively the last key step. Let's just tidy it up a little bit then. 625 over 16 x to the negative 4 thirds.